Okay, hello everyone. Yeah, I was supposed to talk on Friday, so it has been a good night for me yesterday after the speaker dinner. So I'm Éric Leblond. I've seen my name already told today. Thanks a lot, guys. I'm the co-founder of CTO of Stamus Networks, and I'm too tall for this mic. So I'm a contributor on SuriCata since 2009. In my past life, I was working on the Linux firewalling on the NetFilter project. And at Stamus Networks, we are a company that is providing a set of open source tools on the product that is based on SuriCata. And if you don't know what to do when coming back from SuriCon, I can suggest you a free book that we are publishing at Stamus Networks that Peter and myself wrote, and we have a second edition that is available. Yes. I want first to start with a little rewind on Dataset, which is a feature which has been introduced some years ago, but that is not well known. And as I'm going to build in this talk and explain you what I'm proposing on top of Dataset, I'm going to first describe it. So the concept of dataset is really simple. In a lot of cases in security, you have a list of things you want to match on. And if you want that in SuriCata, as mentioned by Victor, you need to be fast. So you want to do it high speed. So in SuriCata 5 or 6, 5 I think, there was the introduction of sticky buffer that was a complete rewrite of the detection engine with new keywords that were allowing you to more elegant construct in terms of rule writing. And the dataset was one of the first new keywords to benefit from this system. So the concept of dataset is the following. You have your signature. You can filter exactly like you were doing before. For instance, I want to check on the file name. I'm going to pre-filter on the fact that it's an executable and that it's at the end of the executable. And then I'm going to check if this element is not set in the list of good executable that I've loaded, from the hard drive. So you got the is not set, you got the is set that allow you to do the simple test or the negative test. So if you look at IOC matching, the interesting thing is that you can use the same list, so the same dataset, one single memory usage on different signature. You can do it on DNS, for instance, with a list of domains. You can do it on TLS. You can do it on HTTP. You can cross-ready, do exactly what you want. But the fun part with dataset is that you can modify them on the packet path. So for instance, if you want to reference all the HTTP user agent that you have seen in your environment, you can just use this signature that is going to say, I want to alert on HTTP. If I see an HTTP user agent, I want to add it on the set user agent. Here you have a state keyword that indicates that you are going to store it to a file. So at restart of SuriCata, we will start from the exact same point. So it will be stored on disk and it will be refreshed when we have some entry. So the dataset set is going to trigger a match only when the insertion is successful and when there is not already the data that is present. So that's why it is working perfectly for this use case. Then, now that you have these bricks, you can do almost everything you want. For example, collecting the user agent is interesting, but collecting the user agent on exotic destination is a bit more interesting. So you can just do that by combining dataset keyword in the same signature. For instance, you can do alert, HTTP host. We are not in the Alexa 1 million list of HTTP hosts, because we don't really care about ingesting 1 million entry. That's just a little bit of memory. And then you can say, okay, I got an HTTP user agent. It's not wget because we're using a lot wget in my company. And then I want to set this to the list of user agents that are not going to Alexa. So you can build like that a set that is useful for other usage, because you can reference this set in some other signature. So for example, you've got a download of an executable from a non-Alexa user agent. That's something that is interesting for this, so you can build on top of this. And thanks a lot, Philippe, for the example. That's a simplified version of the one we teach in the training yesterday. You got something in Suricata that is not known a lot, which is the config keyword that allow you to change part of the behavior of Suricata from the language rule set. For instance, here what we are going to do is remove top queries from the DNS logging. In the case of DNS, you always have your intranet website, for instance. The hit on your intranet website, they are coming always and always in the DNS log. So you may want to remove that from your log because you don't really care. So you can do this with this trick here. So you do a config instead of an alert. Then we're going to say that we want to disable the logging. On which criteria are we going to disable the logging? We are going to disable the logging on the DNS query that is to my list of top DNS requests that I can build with another tools, or just by doing a learning set, doing some statistics. You invent whatever you want, and you can just load this from the hard drive, so that's easy. Yeah, there is a main bug in Dataset, which is the fact that there is not enough users of Dataset for given the quality of the feature. So please think about it and use it. And there is a real bug on it, and Philippe is working on it to fix it, which is the fact that dataset set need to be put at the end of the signature if ever you want to have it not set the things in conditionally. So it's a little issue, but that's just for the set issue. For the rest, it's working properly. Okay. So dataset, it's about checking a lot of stuff. So you want it to work, you want it to be efficient, and yes, it's fast. It can work on millions of entries. It's dynamic. I did not mention it, but you can update dataset from the Unix socket. And for instance, there is this software developed by my friend Sébastien that is Yosemite, that is allowing you to update, to make a bridge between the software MISP with, that is an IOC management system, basically, doing this bridge between Suricata dataset and an external tool. It's available on a lot of dimensions, so basically everything you can have as an IOC can be matched with a sticky buffer, so you can do it like that. And it's a strict equality. That's one of the problems of dataset. But if you can, in a lot of cases, use a transform that will allow you to modify the input data on the buffer to something that you really want to match on. So it is working properly. The way it is working, you need to connect to an external server, export the data with strings dataset type. You need to encode them in base64, which means that you need to prepare a bit the data, or to have the tools on the other side to prepare you the data. And once you've got the dataset, you can write some signature that are using this dataset, as I shown before. And then you will get one alert per hit. And you got the metadata in all good Suricata implementation, so you will be able to understand what is happening. So for instance, let's take this example. We are going to alert on HTTP host by loading a list of host name in a file. The dataset alert that we get from that is the following. We get the alert event that says that we got an HTTP host on IOC. So the message is helping us to understand that we need to look at the HTTP host name. In this case, mil.geeky.com. And yeah, when we face this familiar issue, computers say it's bad because we don't know really a lot about what we have just seen before. So by the way, do you know why this teddy bear is dangerous? Any idea? Yeah, so this teddy bear is dangerous because his eyes are made of glass, so he can kill little babies. Yeah, so yes, we need more context because just having the data and we don't know what it is. Is it a domain used by a script kiddies, or are we facing an attack by some advanced actors? So we need to have the data available. So it's possible, but it's painful. We need post-processing because we have the alert, we have the signature. We know that this signature in specific is matching on the HTTP host name, so you can script everything, take the signature, check on which metadata field it is working, get the value, connect to the IOC management system to check what is the thing behind. And yeah, that's if you can script. If you cannot script, you are good for some copy-paste, jump from one tool to another, and I think you can have a better use of your time. So as I'm French, I'm lazy, so I did decide to work on improving this to help all my lazy people. Yes, because we have better things in life from doing log correlation and jumping from one tool to another. Yeah, so what is really the problem here? We have the context available in the IOC management system, or it's not an IOC management system. But the context is not present in the event because we are losing it during the export, because we are just exporting the value. So what we need to do is to be able to export the context with the value and get the context in the alert. That's the target here. So I've worked on implementing that by adding a new, what is for now a new keyword. Victor, I'm looking at you. That is named datajson. That read the value on the context and output the context in the event if ever the value, we have a match on the value. The syntax is similar to dataset, it's based on that, and it supports the exact same dataset as with one we have with a regular keyword, which is string, SHA-256, MD5, IP, which is IPv4 and IPv6, and IPv4. I'm not a big fan of complex data format. I did not pick XML. So we have a simple file with a value that can be base64 if ever it's a string, or just for IP, just the string, a comma, and then after you put the JSON. So that's really simple. For instance, you can define a threat actor dataset. You put the IP, you put the threat actor, and then you've got the information. Or you can also use this for inventory. For example, you know that Victor laptop is 10755 in your organization, so you can put some interesting information, like the fact it's one of the best and most friendly pull request firewall. So yeah, so that's really convenient, because what you will be able to do then is to combine that using the data.json that is using the same syntax as dataset, but you have a new thing at the end, which is the key value. The concept is to say, I'm going keyword per keyword usage I'm going to be able to add the data, the context data attached under this key in the event that we are going to generate. So for instance, here, I will have a key inventory for the first source dataset that is going to load the IPv4.json list. And I'm going to have the same for the IP destination, where here I'm going to look at a threat actor. So the result is the following. We got an alert, and inside the alert we got an extra category. We can work on the name. I came with this name extra, but I'm not sure it's the best choice. Then we got the first key, inventory, and then we got bad actors. So we can say that Victor is affiliated with the LSD kitten, because we know it's not a bear. Yeah, so what is the status? So the pull request is ready for rejection. We have Suricata verified tests. It seems I had to fix them late last night, but I'm not sure it's really an issue. Maybe I was just working on the wrong branch. It's kind of a complex work. I had to change a lot of stuff. And changes are requested, and they're really making sense. I need to change my NeoVim configuration because it had some include file that I don't want to add. Sorry for that, Victor. And yeah, so demo. Yeah, demo is like picnic. It cannot get wrong. So let's do a demo. Up, and let's put my glasses because I'm in team glasses. Okay. I hope Kelly is in the room because I got something for her. Okay. Yeah, sorry. Okay, so what do we have? Yes, okay. I'm happy I did prepare my command because I'm lost. Okay, so the thing I'm going to do is... Oh, yes, that's the live demo, the first one. Okay, nice. So, okay, I hope I got Wi-Fi. So I'm going to start SuriCata, but first I'm going to load the SRV rules. So if I do that, it works? Yes. Okay, so what do we have here? So we have a SRV rule that is doing two check, IP DST, so the destination, checking if it's one of the server we have, loading survey.list, and then the client, so basically the inventory concept that you have seen in the previous example. So what do we have in server.rules? No, server.rules, my bad, server.list. Okay, so we got this IP seems to be the IP of SuriCata.io. I'm crossing fingers if it's not dynamic, I'm lost. We need to edit. Yes, so I got some data. It's SuriCata.io, even if we're just going to the IP, and the owner is the OISF. And for client, I think I did not do any changes. No, it's not client. What is it? What is it? No, inventory.lst. Yes, so yes, it's supposed to be my IP. I'm Éric, and I'm a web shop lover. So let's see how it goes. So now I can run my first command. Okay, I'm just going to start SuriCata, listening on a wonderful interface. Yep. Should be that. Yes, okay. So first, it does not crash when it starts. It's a good way. It's a good start. Yes, so yeah, you go here. I don't need you. Then I've got the command 2 to run. That is just going to be the tail on the log file. Ooh. And I think I can zoom out a bit. That should be okay, I think. Yes, okay, so tail. Okay, full screen. Where is my cat? Okay, so I'm just going to tail the file. Okay, I've got no alert, what was expected. Now, if I remember correctly, I should have a little guy. Okay, I can do it here, I don't really care. Yeah. Okay, that's my guy. Okay, so now I can just do a curl on Stamus networks. It's not in the set, and the Wi-Fi is not working, as expected. Yes, okay, we got it. No hit. Demo is a mix. I'm not hitting on everything, so there is a really filter going on. You happy? Yes, cool. So let's fix that. So as you can, the fun thing is that even if you load things, you can in fact enhance them through the Unix socket. So I'm just going to do that. So I'm entering the Unix socket mode. Yes, I forgot an option. Then I'm going to do a datajson add, and I need to zoom out a bit to get my full command. Command 3. Yep. So up that. Yep. Getting it back, and I can now add it here. So datajson add should supposed to be the IP of the server. And then, yes, it's up. We're in. So now we can quit. No, I got another one here. I can not do that, do this one. Nope. Okay, too much shell. Curl. Yes, Tamus. And no, 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 no. No! No! Yes, we got an alert this time. Look. Okay, so Éric, who is the web shop lover, did connect to a website that loves Suricata, which is the Stamus Networks website. And we should be able to... No, that's it. Yep, that's it for now. It's early. It's just an IP alert, so we don't yet have the TLS info. Okay, so that's the first demo because I was completely crazy yesterday. So yeah, you have seen that. Now we can get to something a bit more production-like. So that's, yeah, yesterday I did code the script to connect to MISP and get the data, because what else? Yeah, so MISP, if you don't know it, it's a project from the awesome people at circle.lu in Luxembourg. It's really big in terms of usage. I think we have more than 65,000 instances of MISP that they know about. So people are using it to create communities and then share data, including share data about threat intelligence, including IOC between them. Yep. So you can connect to it via the user interface, or you can connect to it via the API. So yeah, you can export in a Suricata format, so that's cool, but not going to talk about it, just have a few minutes left. Yes, so MISP also can export via REST API, so it's a JSON format, and it contains, the event contains general information about the event and then the attribute, and they are they are publishing at Circle PyMISP, which is a tool that you can use to connect and fetch data from MISP. There is some nice example in the repository. So I did start from last.py, and then I just got my script in a few minutes. So what we just do, that's the script. So basically connect to MISP, get a few variables, so you can run it. So you're going to fetch the last 300 days, for example, or the last 30 days, then say that you just want 100 events or something. And then you are going to, so that's the script, and then the script is creating two outputs. One is the file name, and one is the hostname. So I got a file name list and a hostname list that will be created by the command if I got the option set. The parsing is kind of simple. I get a big JSON, the result, and I've got event inside, and for inside the event, I've got attribute with a list of attributes. So I'm just going to loop on the event, then loop on the attribute. And the attribute have a type. So if the type is a file name, I know that I got chance to match it in Suricata in one of the protocol. So I'm going to use that. And it's same for hostname. So if it's a hostname, I'm doing that. And then I'm building complex things here where you've got the event information, some of the top level information, and then the information about the attribute. So in the info, I will have a human readable text, and then I will have a UUID, so I can do direct correlation in MISP by just jumping to the entry by using that. And then I do my data JSON line, so base 64 and the JSON. And then I write it to a file. So I run this code, and after running this should be here. Yes, it's here. A bit smaller. Up. So MISP, yeah, so I got just a few files. So yeah, 79 files, that's a small instance of MISP with almost no data. And if I look at it, I got things like this, better to GQ thing. No, okay. It's not valid. No, it's not valid. Stupid me, because I got the the base 64 at the beginning. Okay, but we can see that, for instance, we got runner.dll. That is one of a bad guy. for this attack, which is, you will see in, I think you got some Vietnamese accent, so that's why it's Unicode, you cannot really see it on this dump. Yep, okay, so that's it. Yep, so, yeah, I finished at 2:22 yesterday. I love this round number. Yep, so what we are going to do is that we are going to run the script. No, I'm not going to do that. I'm not that crazy. So you have seen the data. I did export it from MISP with the script. That works. I've got two pickup, clean pickup, where we download one of the file, which is a clean.dll from a website. It's a PNG, in fact, but it's named clean.dll. And then we have a host pickup. Okay, command one. Command one, I'm just going to start Suricata on clean pickup, but first let's look at the rules. Yeah, so why I got two of them? Yeah, maybe I should do that, but it's not going to run in the same directory, but yeah, I should kill it. Yep, you're dead. Yep. Why I got two, I don't know. Well, in fact, we don't really care. No, HTTP host. Yeah, no, sorry. HTTP host, that's the checking for the second pickup. And then I got the checking for the first pickup. I got a file name that is in the datajson set. Because I've got all my file name indicator in this file name.lst that we have just seen. So I'm going to run the first example. And, yep, run. Up. So the command line is simple. I clean the data, I run Suricata, and I use GQ to select the alert. Ta-da! Okay, and it failed. But that was planned. But the question is why? So what the result of it is that I run the script, I got data, but I have no alerts. So let's look a little bit inside. In fact, I'm matching on file. So if I look at file info, I should have information with regards to what did happen. So, but first I'm going to look at HTTP. So we see what we have in the pickup. So what we have in the pickup is that I am downloading from one of my personal web server a file ~regit clean.dll. So yeah, okay. So clean.dll is one of the IOC, should match. But if we look at the file info, we have the file info property, fileinfo.filename, which is ~regit/clean.dll, basically the URI. So I was expecting to have a file name, but in fact we got the prefix of a URI, sorry, I don't manage to say this guy, inside the thing. So, okay, that's okay, we can fix that. So we can use a transform, PCRI form, to do a transformation, to remove the prefix, and get the dataset to match on the correct thing. So, not crazy, I got that prepared. No, -2 rules it is. Yeah, so I just add that in front of the initial signature, where yes, I know that the rule writer in the room are going to throw things at me on stuff like this, but okay, for my example, it works. Yes, so I'm going to just remove everything at the beginning and stop at the last slash, and then I'm going to take everything that is after. So PCRX form is working in a way where we are going to get as result the first captured expression, so what is below in the parentheses. Sorry. So yeah, so I'm going to have something. So now I can try the second command. Oh, yes. Okay. Oh, that's better. Okay, so PCRX form is there. Command 2 should be the same run. I just switch the MISP rules to MISP.2 rules. and then I can run it. Yep. And then, yep, we got an alert this time with a crap load of data because we have file. So we got the payload printable, we got the payload, the flow information, the files information. So we got the SHA-256, not the magic, that's interesting. I don't know why. And the HTTP response body, the HTTP response body printable. Here you can see that it's a PNG. Up. And yeah, content type, HTTP, and then what we were expecting. So we've got our data from MISP underscore file, because that's the key what it wants. So the event is, okay, is there somebody that can read that with the accent? I cannot, sorry. And that got this, I got the value in clear. So here, that's simple. If I want to correlate things, I can just say that I've seen clean.dll, it's a type file name, and the UUID in MISP is this one. So you got all the information available directly in the event, no correlation needed. Yeah, so that's the one. And then we can, I think, do the same as the previous one. This time with the second pickup to see how it looks like. So here is the second pickup, which means that we are looking at, yep, something. Let me check. Up, let's run the command. Up, yes, okay, with another alert. We found back our example from before, the mail.donkey.com, where we have an alert. On the wire, we can see that it seems to be a Chinese IPT from the description. So definitely we have the context. It's not a strip kiddies. It seems to be some more advanced team, potentially from China. And which means that we kind of succeed in the initial concept, which was to manage to get all the information inside the initial event. Yep. Yes, I'm in advance. As I was expecting, I tried to speak slow, but I managed to fail. Yeah, so time to pack up. Yeah. I think that datajson is a feature that can be interesting because it provides you more context in events. You can really output everything you want, and it's open some new area. So I know that the people that are parsing, looking at Marcus, that are parsing the JSON, you're trying to be fast, we are going to suffer with the dynamic keys. But yes. I think the initial feedback from Victor was positive. I did update the schema.json, so but it's additional properties allowed because we don't know what is inside. So yeah, I cannot do any magic here. Yes, we can add context to the signature, and I think the initial feedback from the OISF team was positive. Potentially some big rework are needed. The concept from Victor is to potentially merge this into the dataset keyword. I would admit that I don't really know if it's a good or bad idea. I understand the concept, and I just don't know. Yeah, we need to discuss that. Yep, and I've been too fast, sorry. But yeah, time for potentially question. If you have some idea, it's currently work in progress, so any suggestions are welcome, and if we can bring some improvement, that will be definitely interesting. Questions? Remark?
Hello? Hi, can you hear me?
Yep.
Nice. Just a quick question. Recently, there have been a lot of work for schema validation. This new key has a quite wide, it has no schema in the end,
no.
Right?
No.
So are you going to handle that?
So currently we handle that because we say there is no schema under the alert.extra key, which is a way to say you can do whatever you want. So what is your usage of a schema, in fact? Because I would say that if you are inside an organization, potentially you can say the alert.extra key in Suricata need to be used like that. Then you can have your local schema. because I don't see any, because you can use it for inventory, you can use it for IOC checking, so it's really open. So I don't think we can enforce a schema there, but locally as an organization, you should enforce a schema inside the organization.
I was more about how you are going to handle that validation problem, if the schema validators that you are using support that feature.
So I've got the most basic validation ever. I'm checking at the loading that it's correct JSON, which is already a thing. So I'm loading the string, checking that the JSON is valid, and not just using the string. That's what I'm doing in the code. So I'm just checking that it's valid JSON, but not the schema. I don't think we can do something here.
Thank you.
Yeah, so Victor was mentioning that potentially if you're importing from MISP, I should, done the code yesterday, maybe I should discuss with them what would be the schema for MISP import, and then have some sub-schema, and potentially even have the key as a parameter. Not use alert extra, but use alert MISP when it's coming from MISP, and then we could have a schema for MISP that is official. And then if you want to link it with some other thing, you will get your new key inside, and then you do whatever you want with the key. That could be a solution.